So now we're going to talk about part 2 of case study ex2, and this will focus on the particular method that will test primes asynchronously as opposed to in a timed manner, and it's going to show off a whole boatload of other operators that we have talked about to see how you can use them in practice. This again is in the ex2 project in the reactive Flux folder in my live lessons GitHub repository. So here we are in case study ex2. And you can see this time we're going to talk about the test is prime async test method, which as before, as in part 1, will be registered along with test is prime timed. And then we'll run both those methods in the background, block the main thread till we're done, and print the results. So let's go ahead and take a look at test is prime async. Notice that test is prime async is called second. And this figures in the results we'll see here in a second. So test is prime async has all the same fields that we had in part 1, and we'll use some of them here. This starts out, once again, with a string buffer because we need to do this in multiple threads. We have a log callback that will print the results into the string buffer. We're then going to create a scheduler that contains one subscriber thread. So this is the subscriber scheduler, and that's where we're going to check for primality. And then over here, we're going to use Flux create, except this time we're going to make ourselves an async Flux sync. Before, when we did this earlier, we created a timed Flux, which is the one that used the interval factor method to create things every half a second. Down here, we're going to make things with the async Flux sync. Let's take a look at that. So that's also a factor method. And this is going to create a publisher scheduler using new parallel, so it'll publish things in a thread pool with one thread in it. And what it's going to do is it's going to use the range method on the Flux, which again is like this for loop. It's a reactive for loop. It'll go from 1 to max value, so it'll go forever, except we're not going to go forever. We're going to take up to a certain amount in a second. We're going to convert long to Flux. We're going to convert it to long since there's no range long method for some God knows why reason on Flux, so we have to do this explicitly. We're then going to subscribe this whole stream of operators, this whole pipeline of operators here. We're going to subscribe it to run on the publisher scheduler that we created up here, this guy. So that whole thing starting from Flux range will run in the background in that scheduler. We're then going to generate random big integers. We're going to generate an infinite number of them initially. We're only going to allow odd values to get through, but then we're going to limit ourselves to taking only 10 values. So we're going to get 10 values that are big, random, big integers. And we're going to use subscribe to tell the Flux sync, these are what we want to emit. So we're going to emit those 10 guys, and then we're going to have complete signal when we're done. And you'll also notice that we have the do finally action operator here, which will say, after all these things are emitted, dispose of the publisher, so that the application can shut down when everything is said and done. So that's what comes out of the make async Flux sync. It's a stream of values created in a background thread. We're then going to log the values in the background thread, and then we're going to say publish on, which means everything here and down to the end is going to run in the subscriber scheduler context. So we're publishing in one context in one thread, and we're subscribing and checking for primality in a different thread. So we've got two different threads going on here. And what we do here is identical to what we did before. We're going to check to see if the value is prime. We're going to process the results. And then if everything goes well, we're going to display the results. And when we're done, we're going to dispose of the subscriber so that the application can shut down. And here, we're just going to use the then operator. We're not going to do anything else fancy schmancy like we did last time. If you remember what we did before with then was we had this from runnable thing, which displayed the results. This time, just to be different, we're going to use do on complete to display the results. And then we'll just return an empty mono, which is an indicator to the async task bearer, all is done, and we can go ahead and have it shut down when the second and final one of these two asynchronous test methods finishes. And if you take a look at the results, you'll notice that even though test is prime timed is called first, it has this delay in it intentionally. Test is prime async, which is called second. Does not have a delay, so just blasts the results out. And you'll notice that the results are all published on one thread, the publisher 3 thread, but they're all checked for primality in a different thread, the subscriber 2 thread. And once again, it looks like we only find prime numbers. No big surprise. If we ran this long enough, we'd eventually get a prime number in the check. But you can see that this is being done in 2 different threads, whereas the other example all ran in a single thread, which came out of the parallel thread pool that the interval method was using. So that's the walkthrough of this example showing off a bunch of cool features of Flux in the context of asynchronous processing.